I would like to just start out and take a second to thank everyone for taking time out of your busy day to join the webinar today. I do hope that you leave the webinar feeling like you learned something. Quick introduction to Fox Valley Metrology. If you don't know who we are a 17025 ISO accredited lab. We specialize in calibration, repair, and equipment sales. We've been around for about 25 years. We have 5 locations throughout the U.S., headquartered in Oshkosh, Wisconsin. We also have one right outside of Minneapolis in Stacy, Minnesota. We have a lab in Rockford, Illinois. We have one in Fenton, Missouri, right outside of St. Louis, and a new location right outside of Charlotte, North Carolina. So if you're looking for any kind of calibration, you're looking for us to help you out fixing some of the tools that are broken. If you're looking for any new tools in the upcoming year, by all means, reach out to me, reach out to any of your local sales reps, and we will take care of you. If you don't know who I am, I'm Josh Weimer. I am the Director of Capital Equipment Sales here at Fox Valley Metrology. I've been with the company since 2009. I pretty much started out in an entry-level role, going from cleaning gauges to a calibration technician, where I traveled around the country for about 8 years. Then I moved into the inspection lab, where I was the applications engineer for Starrett products. And I also performed inspections. So I kind of have a little bit of that all-around role as it comes to Fox Valley Metrology and how we work. So if you happen to have any questions about the sales process or about how these things work, feel free to reach out to me directly, and I will be able to help you. Fox Valley Metrology started doing these webinars about 6-7 months ago. We really like these training webinars. We feel that they provide a lot of information and training to our customers. Our next series in the webinar is going to feature Wenzel and their productivity on the job floor, focusing on 5-axis measurement and software. So stay tuned. If you're looking for any kind of shop floor CMM stuff, we'll be able to help you out with that next month. Today, we're going to be working on taking a look at exploring the benefits of optical comparators and digital comparators, brought to you by Jerry Heiler at Starrett. Starrett's based out of Laguna Hills, California. We've been working with Starrett for several years. We truly feel that they provide some of the best optical comparators and vision systems out in the market. Their support after you guys buy one is top notch. We help out at Fox Valley Metrology. If you're local, Starrett will always be there for you if we physically cannot. So just a little bit of logistics about today's webinar. If you look over on the left side of the screen, you can see a Q&A box. Feel free to utilize that. If anything comes up throughout the presentation that you have a question on, feel free to type it in there. I'll try to address it at the end of the presentation, or if it makes sense during the presentation to stop Jerry, I will try to do that for you. If you want to jump in there now and test it out, let us know what kind of industry you're coming from, why you decided to join the webinar today. Feel free to test it out. It'd be great to physically meet you all. Also, the webinar is being recorded for future reference. So if you do have somebody that cannot attend today, you'll get a link shortly after the webinar is done, and you can feel free to share that link with them. Afterwards, you'll be redirected to a page that'll have some more information on Starrett products. It'll also have a form that you can fill out if you are interested in learning more about it. You can feel free to reach out to me directly or any one of your Fox Valley Metrology sales reps. So that being said, Jerry, if you are ready, I would like to introduce Jerry Heiler. He is the metrology product specialist at Starrett, based out of the Laguna Hills location. So Jerry, thank you for joining us, and we are ready to get going.
Well, thank you, Josh, and welcome everybody. My pleasure to do this webinar for you.
Excellent. So that being said, I think we're going to start out on the optical comparators, correct?
That's correct.
All right. So Jerry, can you explain to us what the most common light used on an optical comparator, and how does that work in order to get us an image?
Sure. Well, today I'm going to be doing the demo on the HB400. This is our mid-level system. It's a bench top, and I'll go into more detail on the different types of options you have as far as the comparators and so forth. But the most common lighting, back to your question, is profile lighting or backlighting, and this is the source of the light. On this particular model, we're using LED lighting. Other systems on the market you may find that are halogen. One of the benefits we see with LED is that you're talking tens of thousands of hours a life, whereas a halogen, you're looking at hundreds of hours. So just to kind of go over the nuts and bolts of it, so we basically have a projector going onto our part. The light that gets through is creating an edge on the screen, okay? So everything, so in this case, we have a hole, it's actually going through that. Anything on the part that is blind, if you will, you cannot see. So we have our light being projected onto the part. That light is then going through the lens. That lens then projects it onto mirrors, which are back here. And then that goes onto our screen as a shadow. Some of you may have heard this referred to as a shadow graph. Now, different comparators are going to have a different number of mirrors. This particular unit has 2. There are some that have 1. The main difference is that with 1 mirror, your image will actually be upside down in addition to being mirrored or backwards. This particular system has 2, so it's been corrected. So it is right side up. It is still backwards or mirrored though. So like I said, that tends to be the most common. And as you can see, we can on the screen see our edges.
Perfect. What would be the case if we needed to get an image on the opposite side of the part? How would you accomplish that on the machine?
So we use, so you need to use surface lighting in this particular case. We use fiber optic. It's through an LED light source. And that is just turned on. We can turn that on here. I'm going to put a cover so you aren't blinded by that. And then as you can see, we now have an image on the screen of the surface. Now, the way this works with the system is instead of the source coming from the back, it's actually going onto the part, reflecting off the part, going back through the lens and then over the mirrors and so forth. As you see, our surface lighting is pretty decent. We tend to think we lead the industry as far as that goes. I think, I'm hoping you guys can see that pretty well. You can see it okay, right, Josh?
I can see it great, and I would definitely say that is better than beyond decent. That is phenomenal surface lighting. Comparing it to other systems that I've seen when I was a calibration tech, it's very difficult to see images on the surface, and the lighting and image that you get off of the Starrett unit is extremely good.
And one of the common problems you have with surface lighting and even backlighting is ambient light, as you've seen when you've been out calibrating and so forth. Today we're in a room with a number of different lights, so we have a pretty good ambient source. As you see from our comparators, there's really not much difference that it makes on the actual image itself. That's one of the benefits of LED lighting. However, sometimes if the lighting source, especially sunlight, is too high, you can get a curtain or maybe put it into a dark room. That tends to be a fairly common method.
Sure. So the ambient lighting on the Starrett unit is not going to affect the measurements all that much, correct?
It typically doesn't. Now we do have some floor standing models, some much bigger models where we're using halogen lights. Sometimes the ambient lighting does interfere, let's say on the shop floor. In that particular case, there is an option to enclose the comparator itself if you need more of a dark environment.
Excellent. So can you go into the different magnifications that are available as it comes to standard optical comparator?
Sure. So the lens I have in here right now is a 10x magnification. It tends to be pretty standard. This right here is a sample of the lens that goes into the HB400. This is pretty common with all of our bench tops as far as size goes. With our larger floor models, it would be significantly bigger. As far as the magnifications go, we follow pretty much the industry standards. you've got a 10x, a 20x, 25x, 31.25, 50x, and 100x. So these are all telecentric lenses with a nice depth of focus. There is no need to recalibrate every time you put in a lens. We use just a standard bayonet process, so it's very easy to replace these on the fly, if you will.
Sure. And there are units available that have multiple lenses, correct?
That's correct. So this step up from this is, like I said, our mid-range system. We have another model called the HD as in David, HD 400. It's got a dual lens system with a sliding bar, so you can put two in if you find yourself, let's say, jumping from a 10x to a 50x. Instead of manually changing those out, you can slide those back and forth, and it switches for you. Now, one of the things we do offer as well is a video option. So in an HD 400, you can use one of those bays as an actual camera lens. It's called the OV squared. And we can, those in the audience who would like to learn more about it, Josh or somebody else at Fox Valley can certainly provide more information for you on that.
Absolutely. So now we've kind of talked about lighting. We've talked about the magnifications a little bit. What do we need to do in order to get that stage to move in order to actually move around on the part?
So there are really two ways of two methods you'll find in comparators and also video comparators. Manual process. This tends to be pretty standard on comparators. We tend to find at least 95% of all comparators use a manual movement process. So actually, a number of our higher end systems, you have a motorized process to move the stage. So in this case, we're moving our X just by moving the knob. We do have a quick release option, so you can move the stage. Okay. We also have our zoom. Now, if you think about it, this is actually equivalent to our Z. We have a horizontal system here. This is actually our Z, which is our focus. And then even though it's going up and down, this is actually our Y. Okay. The other thing is that we've got our protractor here. So and it may be difficult to see on the screen, the crosshairs here, but I'm actually moving this, and you can see my Q axis is moving. Now, these three axes, the X, Y, and Q, have encoders in them, and that counts how many steps, or as you move it, it's recording that distance up to, I believe, about a half a micron accuracy on those. So,
Excellent.
and as far as CNC goes, I'm going to be showing a system on the video side with CNC, so you can see the differences and the benefits of that.
Sure. So even though it's a standard system, the accuracies are there in order to be able to follow these blueprints and these tight tolerances, which is awesome. So can you go into the most basic way to get a measurement on an optical comparator if somebody just wanted to take a visual check on it?
Sure. So comparators have been around for 80 years or so, even more. The typical method for making measurements on this is with what's called an overlay. This is a Mylar overlay, and it may be difficult to actually see this, but there is an etched image on this. And these are all specific to the particular magnification of the lens that you have. In this case, this is a 10x. It's got a grid on here, and you can put this on the screen. So instead of a horizontal and vertical grid here, you can use radiuses, you can use angles and so forth. But once you lay it on the screen, then you basically come in and adjust your image on the screen, and then you can find whether it falls into that particular overlay. So this is a go, no-go process, very visual. You tend to find this with parts that maybe have wider tolerances, and because there is some subjectivity of the user.
Sure. So looking more at a pass-fail thing here, something that you could check really quickly, get in and out, get back to the manufacturing floor, and start making more parts, which is great.
That's correct. Yep.
Excellent. So how do you track what the encoders are reading if you wanted to get an exact measurement on, the diameter of that circle there?
Sure. So one of, as I mentioned, these three axes have encoders on them, and they are actually tracking that distance. Now this over here, this is called a DRO, digital readout. We have 4 different options on this. The one I'm showing you today, it's called the MX200. It's made by a company called Metrology. In addition to tracking positional accuracy, you can do geometric measurements. So for instance, circles, lines, and so forth. So in its basic form, we can measure a circle based on just a readout, positional readout. So I'm going to move this. I'm going to turn off my surface lighting here, and I'm going to move this. And I know it may be hard to see, but we have a crosshair right in the middle of this screen. I'm going to visually put this crosshair down at the bottom of this circle. And then I'm going to go over to my DRO. I'm going to move this in Y. So I'm going to set my Y to 0. Then I'm going to move this up to the top where my Y line crosses the top of the circle. And then I can see that we're looking at basically 0.343 of an inch. Now this can actually measure in inches and millimeters as well. If I wanted to measure in X, I could come over here and get my crosshair on the edge there, set my X to 0. And instead of scrolling with my hand wheel, I can just release this and move it over here and then do a fine adjustment with my knob. And we've got now have 2.5 inch. So that's real big, and we can also do that with your protractor as well. Quick checks, you just want to find a quick distance. This is a nice way to go. Now, what we can also do with this particular DRO, we do have an entry-level one that is position only. This one actually offers some geometric measurements. So if we wanted to, we could come over here and measure this circle a little more accurately by selecting my circle option on the DRO. And what it's doing now is it's just waiting for me to capture these points. So my crosshairs, I find where the center of those, I put it on the edge, I touch my screen, and they just captured 1 point. I'm going to move my crosshairs down to another point, another edge here, and move it over here. And those that are familiar with this know the circle needs a minimum of 3 points. Done. And there we go. So this is a little more accurate than the way I originally measured it, because I captured 3 points. The more points you capture, it tends to be a little more accurate. Then you can measure form and other capabilities on here. So some of the other geometric capabilities are we've got lines, points, and angles. Now, I'm going to do one more thing here so I can show this to you. I'm going to measure another circle using the same method I did before. I'm just going to capture these 3 points. And now if you can see on my readout, I have 2 circles. When I have these 2 circles, I can do a distance between them. I select distance, select circle 1, circle 2, my check mark, and this shows you the distance from the centers. I know it may be a little hard to see on the screen, but this is a change button. I can actually change this within the readout. So instead of centers, it actually gives me my nearest, and you'll see the length here. My L value changes as I do that. So that's to the nearest, and that's the furthest. So this particular readout has like a number of capabilities in addition to geometric measurements. We can actually do constructions, midlines, points, intersections, things like that. It also has some GD&T capability, so true position, concentricity, and so forth.
Excellent. So I know my eyes aren't that great. So if I wanted to increase the accuracy and have the machine go and take some points for me, I see that little wand on the left side. Can you explain the optical edge detection for us really quick?
Yeah, absolutely. And I think your question brings up a great point, which is we're working off a crosshair here. So there's a lot of subjectivity inherent in it. Now, if my particular part, let's say, is an injection molded piece of plastic, there are wide tolerances there. So it maybe in that particular case, it doesn't have to be exact. However, even my measurements can vary based on my eyes, depending on the day, the time of the day, and so forth. So I may not be that accurate. Certainly a room full of 4 people, you're going to get 4 different answers, and we may not be repeatable as well. In those particular instances, you may want to look at what's called the optional edge detection. And this is a fiber optic process, actually has a sensor inside. So once you go from light to dark, it automatically captures that particular point. Now, I'll show you how this works. We're going to change our sensor here, actually our probe, to go to an edge detection system. And it's real simple. We go through a calibration process that says, go to a lighted area, click next. So it knows where a lighted area is, because you can adjust the light on this. And you also have some different results depending on what material you're using. This says, now go to a dark area. So we move this sensor to a dark area. And then it says, go back to a light area. Done. So now we're actually using this edge detection device. So if I now want to go to measure a circle, as I move from my dark to my light, you're going to see that it actually captured that point automatically. And then I'll move down here. And you see, this is actually a very fast process. So in the same amount of time it took me to visually measure 3 points, I've captured 8 points. And this is probably the most accurate way and repeatable way of doing this measurement. Like I said, this is an option on all of our systems. It's not something you have to have, but it is an option.
Absolutely.
Just one other thing to add is the edge detection works very well on profile lighting, because you need a very clear contrast between light and dark. When you get onto surface lighting, edge detection doesn't work so well. So with your particular customers, if you're finding you're doing a lot of surface lighting measurements, maybe the edge detection isn't best for you. If you're doing a lot of more profile lighting measurements, the edge detection is a nice solution.
Yeah, I totally agree. I mean, getting more accurate and repeatable readings, I think, is what everybody's goal is. You saw how fast you were able to go and take 8 points on that circle, in less time than you took the 3 points. Getting more accurate readings in a quicker amount of time is what every manufacturer wants.
Right. I mean, it helps to handle that nightmare of shipping out bad parts or rejecting good parts.
Correct.
You have the comfort of knowing these are good parts or truly bad parts. So.
Absolutely. So here we are looking at this HB 400. What are some other standard optical comparator units that would be available?
So we have an entry-level system called the HE as in Edward, HE400. It has one mirror on here, as I mentioned. So upside down and backwards. It has a smaller stage. So as I go through these different models, they have different stage sizes or the maximum part you can measure. And we can certainly provide all that spec information afterwards for all your customers. So we have an entry-level system, HE. We have our HB. As I mentioned, all these come with the option of the edge detection. We have the HD as in David, which has the dual lens system. And we get into the larger floor models like the HF as in Frank, 600, 750 that are actually really quite large. These actually, as you've seen, these sit on a bench or cabinet. The larger systems are actually floor standing, so they don't sit on one. So you've got screens that are 24-inch or bigger, and then you have stage movement that is significantly bigger as well. This particular system has a horizontal orientation to it. So your optics are actually going horizontal to the part. And we also offer vertical comparators as well. So your part sits on a piece of glass. you have your profile lighting coming underneath, you have your lens on top, and then you have your shadow or your screen right here to see that as well. So really two different orientations.
Excellent. And then my biggest issue when it comes to optical comparators is how do you get your parts to sit flat on the machine? It gets to be very difficult to fixture them up there. What are some options that are available?
So some of the options, and you'll see it on the HDV, we have vices, we have rotary vices. So one of the challenges you may have is a part may have a unique angle, so you want to adjust it or rotate it on a vice. So you've got the correct, so that particular feature is square to your optics. We have centers. So if you have a turn part and you want to connect it with centers, you have that option as well, or V blocks. So you can just sit your turn part onto a V block and view it sideways as well.
Excellent. So we're about 25 minutes in. Does anybody have any questions as it comes to the standard optical comparators? Feel free to use that Q&A box over there on the left side. Otherwise, Jerry, if you got anything else that you want to add to the standard comparators, otherwise I think we're ready to move on to digital.
Yeah, let's move on over to our HDV system.
Sounds great.
So this is the HDV 400. This is our mid-range, if you will. We have two benchtop models. We have the HDV 300 and the HDV 400. Main primary difference is size. We also do have a floor standing model called an HDV 500. So let me just kind of go through the same format, if you don't mind, of what I did here as far as light sources.
Yes, please.
Yeah, so very similar to the optical comparators, we have our backlight here, and this is LED lighting as well. This projects the light onto the part, goes through the lens, but instead of going onto mirrors, you see there are no mirrors back here. It's actually a camera sensor behind the lens that's capturing this image. It's going through the software and projecting it onto our monitor. Okay. So as I move this, you're seeing a live image of this particular part. Now, where a video system starts to strongly differentiate itself from optical is the surface lighting. If you remember on the optical comparator, we had fiber optics that came out. You could see this surface fairly well in comparison to maybe some competing models. But when I turn on my lighting here, my surface lighting, you see a significant difference, and I'll bring this into light. You can actually read the surface. And the primary difference is because it's actually going right to like I said, a camera sensor. Now, the surface lighting on this is a little different. We're using an LED ring light. And this can detach very easily. We could put it for different lenses and so forth.
Excellent. That's one of the biggest differences to me as I'm showing these different machines to customers is the surface lighting on the digital machine compared to a standard optical comparator. I mean, you can see the optics is crystal clear, and the customers always seem to love that.
Yeah, and if you look really close here, you can see we've got a bevel, a little fillet here. And many times you want to measure that, and that's completely blind in an optical comparator. A lot of turn parts have you want to check the end. Those aren't through features or through holes. So that's really where this starts to have a tremendous benefit over an optical system.
Sure. And how does ambient light affect the digital comparators?
Quite honestly, unless you have a floodlight sitting in front of the part, the sensors pretty much ignores ambient light. We have a number of customers that have these on the shop floor. They are fairly well protected from dirt and moisture and so forth. If you find that you're in an environment where it is rather dirty, we can do a passive air system. But really, ambient lighting in general does not affect this more or less at all.
Awesome. So what kind of magnifications are available on the digital unit?
Yeah, so we, as you'll see, this is a standard lens. It goes in and out of the location, the slot with the same bayonet process as the optical comparator. This one, it goes by a little different magnification levels because we're dealing with video. So this is the one we have in here is called a 0.3x, which is actually equivalent to a 10x. And then from there, we go up to all the way to plus 130x magnification. There are a number of different steps in between there. The other unique thing about the video is we can actually, if needed, we can put a zoom lens on here. So then you can get into very high magnifications.
Awesome. So even though there's, it's a digital camera system, the magnifications are still going to be there. If you need to get something with a smaller field of view, that there's definitely plenty of options available for you, which is great.
And then just one other thing to point out, in addition to the magnifications, because this is video, we can actually do a video zoom. And I'm just using my scroll mouse, so I can go in and maybe check to make sure that my focus is good there. And that's something you can't do on an optical.
Yeah, that's amazing. Basically, like if you were to take a picture on your phone and zoom in a little bit, being able to give you a little extra field of view on there was great.
Correct.
So I'm noticing that there's no bars or handles in order to move this machine. So how does the CNC machine work here?
Yeah, so this particular system is a CNC movement system. So right here, you'll see that we actually have a joystick. And for those of you that may have a CNC, a CMM with a CNC, it's a very similar process. We have our X, we have our Y, and then we have our zoom, which is actually turning the knob itself to move the Z. And just as I mentioned before, our Z in a horizontal case is actually front and back, whereas maybe a CMM, your Y is actually front and back. So there are some benefits. I'm going to run a program for you here in a minute. With a CNC, as long as you've set up your alignment process, you can actually run a part and inspect it unattended. And like I said, I'm going to show you that in a minute. Now, that CNC is an option for this. We could actually use the entry-level system, which does have the knobs for movement as well. Now, one of the things you don't see on here is the knob for the protractor, as you saw on an optical comparator. And I'm going to touch on that because we don't need that within the software. We can automatically correct for any type of skew, if you will. And there is a benefit to that because I'm going to be showing you how we use overlays.
Sure. So I mean, we're here looking at basically a monitor. There is no buttons on it's a separate readout. So how are you going about and taking measurements on this system?
There are a couple of ways we can do that. We have a number of different probes, and if I go in here, if you've got your users, they really like the crosshair, you can use a crosshair as you did before. Okay, and if you look up in the upper left, as I move this, it's moving my positional information as well. Something that is unique is I can come in here and actually grab my crosshairs and move them. And as I move them, you'll see my position changes. So this gives you dual functionality on your crosshairs. Now, what I like to use and what customers typically like to use is what's called iMeasure. And we can do this on the screen. The screen is actually a touch screen. So I'll just touch the edge here, and it actually measured that edge automatically. So the software is always looking for that difference, contrast between light and dark. So captured that line. I'm going to go into my part view here, and you'll see this line. And in one touch, it captured 92 points. So you can imagine capturing 92 points with your crosshair on an optical comparator could take quite a bit of time. Now, the other thing I could do is I could come in here and measure a circle. And this is just clicking and dragging my mouse. So I can set the beginning and the end. This is nice because let's say if you have a keyway on a circle, we can set the beginning and end of that measurement and completely ignore that keyway. And I'm going to measure the line here and go to what's called my part view, because in this case, what I can do now is I can measure things like my angle. What's my angle between these two lines? And this shows us our results in the upper left there. We can come up and we can mark this a little bit if we want. We can say, there's our angle. We want to check our diameter and so forth. And I'm going to go over and measure the same thing I did on the optical comparator. I'm going to measure this second circle, and I'm going to measure that distance as I did before, and you'll have a better view of measuring those distances here and changing from centers. There's our centers. And then what we do is we choose our change button. That's the nearest, and that's the furthest. Okay.
Excellent. So what kind of differences are there from the digital comparators as it comes to the standard optical comparators? What are you going to gain by upgrading to a digital side rather than an optical side?
Well, one of the nice things on the digital side is, as I mentioned, we don't use standard Mylar overlays. We use actually 2D CAD files for that. So I'm going to put a different part on here. This is a standard demo part that we use. And I'm going to fixture it on our rotary vise. I'm going to create a new program. And get that into view here. And I'm going to, now I used this is just a standard DXF file from SolidWorks. It has its own alignment system, which happens to be my 00s up there. So I'm going to bring in this CAD file, but I need a reference, an alignment reference before I do that. So I'm going to choose, let me undo that. I'm going to do a skew, because you can see my part is crooked there on the screen. Done. And then I'm going to make a line here, and I'm going to set my 00 up at the top. So that's my datum. So now this particular part is aligned to the same alignment structure that my CAD file had. Once I have that, I can go back to my live screen and choose a different probe. This is my overlay, or digital overlay, digital comparator, I think it's referred to. And once I do that, I just do a long press. I bring in the overlay, or the CAD file, which I've already adjusted for 10,000 tolerance. And as I move this on the screen, these green lines represent that 10,000 tolerance plus or minus. And as I move it, the CAD file stays with the file, so you can visually see whether this is in or out. Now, this CAD file is completely independent of what magnification lens you have on the screen. So if I were to switch this to, let's say, a 20x equivalent, it would automatically scale to that size. So no more need for physical Mylar overlays, no more validating them every year. That's done with. Your CAD files are theoretically perfect and they don't change over time. Now, the other nice thing about the CAD file we have here is that we could actually program from that. So let's say you have a more complex part, and instead of going and actually manually program it, we could bring in that CAD file, do the same alignment we did here, but we could program off those features. The couple main benefits of that is speed, but also you're bringing in that nominal information from your CAD file, so we don't have to go in and enter that into our window here. So let me just select something. So as I mentioned, so this is actually what we call our feature detail window. This shows our nominals, and then we can set our tolerances, and this shows our results. So I talked about overlays and using CAD file. The other primary difference you're going to find with a video system is a nice option we have in the software, and that's called our thread module. I'm going to go ahead and put this on the screen here. Create a new program. And you'll see my threads there. Because this is video based, I can just choose my thread module. I can highlight those particular threads. Enter, done. And it's actually measured those. This is my major, this is my minor, this is my pitch diameter. And then we go over here. This tells us this is 9/16. We've got a pitch of 24. And if we want, we can choose the particular class. So usually when I do demos like this in front of a crowd, this is where I get the oohs and the ahs, because, you know, everyone who's used a comparator in the past have tried maybe a 3-wire method or maybe an overlay to check those. This is done very quickly. The other nice thing about this is that I can then show that on a report showing the results of those particular fees and present it to the customer.
That's one thing that I've noticed in the this particular software is the reporting and being able to export your statistical analysis that's automatically built into the software. A lot of people really seem to like that if they're running a lot of the same part, that the statistics are built right in.
And one of the last things I want to show here is I had mentioned on the comparator the CNC capability and some of the benefits. I'm going to run a program that I've already pre-programmed. And I'm going to use a feature called pattern recognition. And this is actually a very powerful function in that I don't, as you saw when I brought in that the overlay, I had to set my alignment process automatically. I'm sorry, manually. So with the program that's been set up, it just needs to find a particular pattern or a pre-alignment, if you will. And then it will automatically do the alignment and then measure the part. So I'm going to just press play. Let me create a new program here. I'm going to press play. Let me bring up this. This one is a slide program. And I'm just going to press play. First thing it's doing is just asking to make sure that I get this pattern into my field of view. Once I click that, it's going to proceed. It's doing my alignment now. And once it's got that alignment, it's doing the measurements, moving the part, it's doing everything automatically. So if you've got a busy shop, you've got a number of parts you need to inspect, this really saves a lot of time. And we can set this up in a fixturing process. So it's just a matter of putting the parts into place. We can do multiples across the stage. And then when you're done, this is our results. So number of benefits you can get out from CNC.
Excellent. Jerry, I did have one question that just popped up, asking if every thread module is included with every system, and how would they know if their system has the thread module?
Sure, it is an option within the software. Not all shops need thread modules. So if it's something you need, you can either place that, request that at the time of your order of the system, or at a later date, if you find that you're doing a lot of thread modules, you can just contact us, and then it's just a different software license. We could do that over the phone or over the web.
Sure. So if they need the thread module and they don't see it on their homepage, they'd just be able to reach out to you guys and get that thread module license.
That's correct. Yep.
Excellent. Okay. I think we're pretty much wrapping up with the digital side. So do you want to go through some of the similarities between the optical comparators and the digital?
Sure. So really is what I've shown you here, the similarities. The primary similarity is just the orientation. I have the benefit of visiting a number of different shops on a weekly basis, certainly more pre-COVID than today. But this horizontal orientation you find most job shops are using. Some vertical orientations you find in medical device companies, but primarily this. So you see this, you see the same stage. The other similarities is it's a bit of an industry standard. So a number of users of comparators and already find these similar, and they feel comfortable with them. These are also they have the same frame, so they're very rugged. So the frame on this is almost identical to the frame on our mid-level system here.
Excellent. So what would be the benefits of having that optical comparator sitting there on your right?
Well, one of the reasons why, some of the reasons why customers would go an optical comparator is price. They just don't have the budget of getting into a video system. You can get a nice entry-level optical comparator for $10,000 to $12,000. Good function machine is going to last you a number of years, get a nice readout. So that's really one of the primary benefits to that. The other thing is familiarity. A number of customers that the guys on the shop floor already know how to use a comparator, and so that's a preference. Is it the fastest solution? Maybe not, but what you use is really the most important, and what you can use well. Like I said, they tend to hold up a little better in real dirty shop floor environments. I don't see too many of those anymore. I remember the old forging shops, and even just regular shops. There's so much dust and moisture in the air. It's almost embarrassing to bring in a customer. Now you just see very clean shops that are very attractive. You can almost eat off the floor, if you will. So let me jump on to maybe the benefits of the digital then. As I mentioned, let me get to my live screen here. As I mentioned previously, when you're using a crosshair on an optical comparator, if you've got a part with real tight tolerances, there's some subjectivity that comes into play in measurement. So with video, we've got a touch screen. There's significant benefit to that because the software finds those edges and is very accurate and very repeatable. The other thing is the lighting on a video-based comparator. It's significantly better than what you're going to get on an optical comparator. And this is important for all your blind features and so forth. The other benefit you're going to see is using CAD files as an overlay. So you no longer need Mylar overlays for all the different magnifications you have. You don't need to validate those every year. That's all brought in automatically within the system and then placed within the part, and you can do some quick go no go. And we can also program for those CAD files. Sure. The other thing is the optional thread feature that can save you a lot of time and provide real accurate measurements on measuring threads.
Sure.
So I would say those are the primary benefits between the two.
Yeah, absolutely. And even just having that, the software be able to take those points for you. You had touched on the improved accuracy and repeatability of the software, or the optical edge detection being able to take those points for you. Having that digital system where the machine is going to be exact every single time, that's going to give you a little bit of peace of mind. It gives your customers peace of mind as it comes to knowing that you guys have the top of the line software and machine getting good parts out to them.
Good, correct. So, I mean, I'd love to hear some questions from the audience if you wouldn't mind.
Yeah, absolutely. If there's anything else, by all means, that Q&A box is still open. Otherwise, I think we're about done. So if anybody has anything else that they want to know or have any questions for us, by all means, you can reach out to the email addresses on the screen. I don't see anything else popping up.
Okay, well, let me close by saying, once again, thank you. I really appreciate this. For those that are listening, we highly encourage you to work with Fox Valley Metrology. They're really high valued dealer of ours. They provide the calibration, installation, and services and so forth. And Starrett in general, we look for those types of dealers to make sure that they can support the customers in the best way, and they're very responsive.
Absolutely. We do thank you, Jerry. You've been extremely knowledgeable and extremely helpful, putting on a great presentation for us today. I hope that everybody who attended was able to take something away. Again, if you have any other questions, feel free to reach out to Starrett or myself. And then just a reminder to watch your email, check our website. Our next presentation will be with Wenzel CMMs. So that will be taking place middle of next month. And if you have anything else, let us know. Otherwise, we will speak for Foxvale Metrology and Starrett. And thank you all for your time today. Watch your email.